Unit 1, Relations and Functions, Section 1, Function Operations. This is Chapter 10 in your textbook. Okay, so there's just the one curriculum outcome, and we are going to demonstrate an understanding of operations on and compositions of functions. Okay, there's 3 parts to this chapter. Part 1 is the sum and difference of functions. Okay, Part 2 is the product and quotient of functions, and Part 3 is composite functions. Okay, there's notes and then some practice after each video. Okay, then there is the function operations review, so that's a formative assessment. The function operations curriculum review, that's a summative, so that one counts for marks. And then there is a function operations quiz, so that's like a chapter exam. And then we have our Unit 1, Section 1 exam. So that is on chapters 1 and 2, function transformations and function operations. Okay, so let's get started. Okay, Part 1, Sum and Difference of Functions. Okay, you can form new functions by performing operations with functions. To combine functions, to combine two functions, f of x and g of x, we can add or subtract as follows. So if we want the new function h of x to be f of x plus g of x, we can write it that way. Or one other notation is to actually write f plus g of x. Okay, so we can combine those two and it's all good. So same thing with difference of functions. So we get a new function by subtracting the two, which we can shorthand into f minus g of x. Okay, the domain of a sum or difference of functions is the domain common to both or all 3 or more of the original functions. For the range, it's easiest to look at the new function and simply graph it. Okay, sometimes you can get the range from the new equation, the h of x equation, but typically it's just easiest to graph and see what happens. Okay, being able to analyze a graph then with your calculator is a very, very good skill to have. Okay, so example 1. Determine the sum of two functions. So I want you guys to consider f of x being 2x plus 1 and g of x being x squared. Okay, so determine the function, the new function, f plus g of x. Well, really, sometimes it's easier to think of it like this, f of x plus g of x. Okay, which of course is, so that's going to be the h of x function now. Okay, so that is f of x, so 2x plus 1, plus g of x, so plus x squared. Okay, so that is a good enough answer, but usually when we have functions, we write in descending order of x. So that would be x squared plus 2x plus 1. Okay, and we know that that's a parabola. We could find the domain and range fairly easily of that. Anyways, we'll get there. So for B, sketch the graphs of f of x, g of x, and h of x on the same set of coordinate axes. So it's the same graph. Okay, so the first one, f of x, that's 2x plus 1. So remember, that graph is linear and it has an x or a y-intercept at plus 1. Okay, and the slope of 2. So we go 2 up, 1 over, 2 up, 1 right, 2 up, 1 right, or 2 down, 1 left. Okay, so really easy line to draw. We've been drawing this for a while. Okay, and let's see how steady my hand is. Okay, that's pretty good right there. Okay, now the second one, okay, so that's f of x. Okay, so tell you what, I'm going to draw in, let's draw this one in green. Okay, so then x squared. So we know all about x squared. We have the vertex at 0, 0, and then it follows that nice over 1 up the odds pattern. Over 1 up 1, over 1 up 3, over 1 up 5. Okay. Again, you don't have to do it that way. You can use a table of values or just whatever. Okay, so that's awful close right there. Okay, so now I'm going to draw in orange. Now orange is the sum of the two functions. Now remember, f of x is just typically a y. So g of x is also a y. Okay, so really what we're doing when we get h of x is we're just adding the y coordinates of the two functions. Okay, so if we do that, Okay, let's see. Let's start right on the y-axis here. So look, this guy's point is 0. This guy's point is 1. When you add them together, you get 1. Okay, so this guy here is a point on the graph. Okay, so let's look at the point x is -1, so right here. So that's the y value there is -1. The y value here is +1. -1 and +1 make 0. Oh, okay. So let's look here. So the y value here is -3. The y value here, 1, 2, 3, 4. Okay, so -3 plus 4 is +1. Okay, and let's keep going. We'll just do a few more. Okay, so 1 and this is 1, 2, 3. So 1 and 3 makes 4. So that's this guy here. And we'll try one more set. So we'll go down to here. This guy, his y coordinate 1, 2, 3. So -5. This one's is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so -5 plus 9 is +4. So 1, 2, 3, 4. Okay, and that's good enough for those. So look, it makes a parabola that looks like this. Well, interesting, because that's this graph, x squared plus 2x plus 1. Okay, not a big deal. We kind of know a little bit about that orange graph. Okay, so state the domain and range of h of x. Okay, so h of x, the domain, okay, that is x is an element of the reals. The range for this guy is y is bigger than or equal to 0. So just for interest's sake, let's put on f of x and g of x as well, just to see. So the domain for f of x, so that was x is an element of the reals, and it's a line, so y is an element of the reals as well. Okay, so the g of x, okay, that was x is an element of the reals, and y was greater than or equal to 0. So you can see that the domain is the same for all three. It's everything. And the range was the stuff that was this common between the two things. So we have f of x was everything, g of x was greater than or equal to 0. So you can see the range is just comes from the g part, the bigger than or equal to 0 part. Okay. Anyways, determine the values of f of x, g of x, and h of x for when x equals 4. So all we do for that is we just put in the value of 4 for all the x's in those equations. So if we go back up to here, f of x, 2x plus 1. Okay, g of x was x squared. And h of x, we said, was x squared plus 2x plus 1. Okay, so so f of 4 then, just put the 4 into there, so 2 times 4 plus 1, well, that's 9. So g of x, or g of 4, would be 4 squared, which is 16. And then h of x, so h of 4, would be 4 squared. Okay, so 4 squared plus 2 times 4 plus 1. Okay, well, let's see. 4 squared is 16. 2 times 4 is 8. 16 and 8 makes 24. Plus 1 is 25. Now, I would like to draw your attention to, oh, look. The equation h of x is f of, whoops, funny, f of x plus g of x. Okay, now remember, f of x was 9. Well, h of 4, f of 4, g of 4. F of 4 is 9, plus g of 4 is 16. Well, what's 9 plus 16? Well, it's 25, which is what we got for h of 4. So 25, of course, equals 25. So we can do it from the equations, or we can do that just by adding the two functions together. It's really quite neat. All right, next up. Okay, so what about the difference of two functions? Okay, so now we're going to subtract. Okay, not a big deal. So h of x is just going to be, so f of x minus g of x. So f of x is root x minus 1. Okay, and then minus g of x. So minus, now when we subtract stuff, we want to make sure that we're subtracting the whole function. So I put in brackets for that, and then we can get rid of the brackets when we simplify. Okay, so that's going to be root x minus 1. Now that negative distributes evenly into both those parts, so minus x plus 2. So there's our h of x function. Okay, so now we want you to draw those three graphs, f, g, and h, on the same coordinate grid again. So x minus 2, like that's the easy one, that's a line. So that's just a line that goes through negative 2, okay, and has a slope of 1. So that means 1 up, 1 right, 1 up, 1 right. Okay, so it makes this nice little diagonal line. Okay, and that goes down as well. And let's see how steady my hand is. A little wobbly, but not too bad. Okay, that's that one. So that is g of x. Now, I guess I should write in a different color for... Okay, so f of x, root x minus 1. So we know what the root graph looks like, and it's just been shifted over 1 to the right. Okay, so the root graph starts here. Remember, that was from last section. The root graph starts like this, and it's kind of an inverse quadratic graph. So instead of over 1 up the odds, it's up 1 over the odds. So up 1, right 1, up 1, right 3, 1, 2, 3, up 1, right 1, 2, 3, 4, 5. So it just makes it really easy to draw those graphs. Okay, there we go. Okay, now, okay, so there's that one. That's f of x. And one more different color. Let's use a red for this. Okay, so now, of course, we're subtracting the graphs. We're subtracting the y value of, so it's f minus g. Okay, so if we do that, f minus g, so the f is the blue graph. So let's look at this, the point at x equals 1. Okay, so f of x is 0, so we're going to have 0 minus, and then g of x there is negative 1. Oh, well, that's just positive 1. So our g of x graph looks like that. Okay, now here we have the f of x graph. Okay, here f of x is 1, g of x is 0, so f of x is 1 minus 0, so that's also 1. So that graph looks like this. Now, it's kind of hard to tell because the graph isn't all that accurate. But look, this is like negative 0.8. That's like positive, like 0.3 or something. I don't know, 5.5 maybe. So we have 0.5 minus negative 0.8. So it's just a little bit higher than 1 here. Okay, so you'll see that when we actually graph it on our graphing calculators, but yeah, don't worry about it for now. It does go up a little bit higher. Okay, now this guy here, let's just try a few more. Okay, so f of x is, I don't know, like 1.2. G of x is just 1. So 1.2 minus 1 is 0.2, so it kind of about there-ish. But now, see how the orange graph goes above the blue graph? So this is like, I don't know, 1.8, 1.9 minus 2 point something, so that's negative. Kind of looks like that. Here, let's go forward to like this one. So this guy, f of x is 3, but g of x is 4, 5, 6, 7, 8. So 3 minus 8, that's negative 5. So 1, 2, 3, 4, 5. So the graph goes all the way down to there. So if you just have a look, again, I kind of need a steady hand. That was not what I would call a steady hand. Sorry. Okay, so kind of like up and like that-ish. Okay, so very strange looking graph, but it's interesting at least. Okay, so all we did is we subtracted the two y coordinates, f minus g, okay, to get that one. Okay, so go ahead and graph that on your graphing calculator. It actually looks pretty close. Here, we'll do that together in a minute. Okay, regardless, state the domain of f of x. Well, f of x, that was this guy, so the domain of f of x, that is x is bigger than or equal to 1. The domain of g of x, that's the line, so that's x is an element of the reals. And h of x was x is bigger than or equal to 1. Okay, and that should make sense because the root graph doesn't exist back here, so the h of x graph can't exist there either because it's the two y coordinates subtracted. So, okay, good. Use the graph to approximate the range of h of x. Okay, so if we look at the range of h of x, I don't know, is that close to 1.5? I suppose it is. So that would be y. So the range, so y. Sorry guys, I kind of zoomed in so the writing isn't. Okay, so y, the range is less than or equal to, well, whatever that number is. On our graph, it kind of looks like 1.5-ish. Okay, we said round to the nearest tenth, maybe 1.4. Okay, it's kind of hard to read on these ones. Okay, which is why I'm going to have you graph h of x on your calculator and actually find the range to the nearest hundredth. So find that top point. Okay, so when you do that, really quick, so I will graph that as well, and then I'll take a picture for you guys. So, okay. So graph. So what we're going to do is we're going to graph h. So that is root x minus 1, okay, minus x plus 2. So when you graph that, okay, it comes up on your screen just like usual. And how we find that point is we want to find a maximum point. Okay, so that's no big deal. We just now I use a TI Inspire, but lots of people use TI 84s. So for the TI Inspire, we go menu, analyze graph, and then maximum. So that's menu 6-3 to get the maximum. Okay, you guys have seen this before, so it's not that it's new. Okay, and when we do that, we actually get a maximum point of 1.25 and 1.25. Wow, it's neat that it's symmetrical like that. Okay, but regardless, we want the range, so that's the y coordinate. So this and to the nearest hundredth, so that is y is less than or equal to 1.25. Okay, and I'll just take a quick picture of that for you guys. Well, it's still recording, so I can just kind of show you on here. Okay, sorry, it's a little fuzzy. Ah, there it is. See, there's the graph. So, of course, we want the y coordinate for a maximum minimum, and that is the 1.25. Okay, awesome. So we'll go back to where we were. Great. Okay, so that is that one. Marvelous. Okay, so number 3. Okay, sketch or determine a combined function from graphs. So I want you guys to sketch h of x equals f plus g of x given the graphs of the two. Okay, well this is not so bad because once we have the graphs, then it's actually quite easy. Now look, my graphs are red and blue, so I'll graph in orange. Okay, so we want f plus g of x, so that's f of x plus g of x. We can expand it out so just to get a better idea. Really what that means is we're adding the y coordinates of f to the g coordinates, to the y coordinates of g. All right, so tell you what, let's look at these guys. So f of x plus g of x. So let's start right on the y-axis. Why not? So we have f of x is 1, and g of x is minus 3. So 1 plus minus 3 is negative 2. Okay, so if we go look at x is 1, so I've got 2 plus negative 4. Oh, okay, so 2 plus negative 4, hey, that's also negative 2. Okay, this one I have 3 plus negative 1, 2, 3, 4, 5. 3 plus negative 5, hey, that's also negative 2. Okay, we got 4 and negative 6, which is negative 2. And look, we get a whole bunch of dots that go this way. Does that work going the other way too? So this one, f is negative 1, g is negative 1. So negative 1 plus negative 1, oh, is negative 2. Okay, this one, f of x, is negative 2 plus 0. Hey, that's negative 2. Okay, and then over here we have negative 3 plus 1 is negative 2. So look at this. You get all these crazy coordinates that make a line like that. So there is h of x. Okay, and then what's the equation for h of x? So remember, a horizontal line is just a y equal line. So this is y equals negative 2, or if you prefer, h of x equals negative 2. So that is the equation of the line. Okay, great. Okay, example 4, the application of the difference of two functions. So, number 4, Reach for the Top is an academic challenge program offered to students across Canada. Okay, suppose the cost of t-shirts for the program includes $125 in fixed costs and $7.50 per t-shirt. So the $125, that's like the setup and the just what all companies charge, that the setup fee, and then you have a cost per shirt after that. T-shirts are then turned around and sold for $12 each. So A, write equations to represent, okay, the first one, the total cost, C, as a function of the number of t-shirts, N. So the cost of the t-shirts, okay, so you say that C of N equals, okay, so we got $125 fixed cost. Even if we make no shirts, just by walking in the door to this company, they're going to charge us $125 plus $7.50 for every shirt, and N is the number of shirts, so there's our function. Okay, now we're going to have a revenue cost. So revenue is the money we generate or bring in. So the revenue, as a function of the number of t-shirts, the revenue is, we sell them for $12 each, so it's 12 times N. Okay, so those are our two functions. Now, on your calculator, graph the total cost and the revenue functions on the same set of axes. Okay, you're going to have to change your window, okay, and then write your window settings in the space below. Okay, where do the graphs intersect? What does this point of intersection represent? Okay, so here's the thing. There's no real right or wrong answers as far as the window settings, as long as you can see the intersection point. Okay, so what I did is I graphed them, and you can't see much, so I'm like, okay, well, fine. You know that you're paying at least $125, so our functions are cost and N. Now, of course, your calculator doesn't do C's and N's, it does Y's and X's. So your cost is at least $125, at least. So your Y value won't even start for that one graph until 125. So what I did is I actually went up to 500. Okay, that was my Y top. And then, I tried a bunch of different numbers, and I finally settled on 50. And 50 shirts, and then I could find the thing. So graphing this, now remember the window settings, okay, they go X min, X max, and X scale. Now, there really is no wrong answers for scale. So how we do this, the x minimum, I just left it alone. I said it was -10. The x max, I went up to 50. And the x scale, I went up to by 5s. That's good enough. Okay, and then the y's. Okay, so the y value, I just left it whatever the graph was at. I think it's like -6.67 or something. Okay, and then we went up to 500-ish, and a good number to go up by there is 50. So you can change your window settings and graph those two functions, and then it'll actually work. Okay, so anyways, so you graph them. All right, the window settings, so we did that. Where do the graphs intersect? So on my graph, they intersected at 28 and 333. Okay, and that's rounded. And my calculator for this one graph just rounded to the nearest whole number, which makes sense because you can't have a decimal of a shirt. I think on normal settings, most calculators will give you 27.8 and 33.3. Now you can't have 27.8 of a shirt anyway, so we just round that to 28. Okay, that's great. Now, what does that intersection point represent? Well, here, I'll just make a quick sketch here. You have a cost function, okay, that's like this, and then a revenue function like that. When they meet, so that means your cost and your revenue are exactly the same thing. Well, we call that the break-even point. Oops. The break-even point, where your cost and your revenue are exactly the same. So you haven't made any money, but you haven't lost any money either. Okay? Now, I did actually take a picture of this graph, so I will show it to you, just so you can have an idea of what that looks like. Okay, so that is this one here. Done. Okay, so 2833.33. Okay, and you can see the graphs. Now remember, your calculator doesn't graph ends either, so that's why there's an X here, okay, and a 12X. So not a big deal, right? The X's mean ends, that's fine. Okay, all good. So you graph the two, and then there's your intersection point. So again, what that means is your break-even point is 28 t-shirts. After 28, your revenue graph is higher than your cost graph. So after 28 shirts, you start making money. Below 28 shirts, you're losing money, right? If you don't sell 28, you actually end up losing money. Okay. And then the last couple here. Okay, so the profit is the difference between the revenue and the cost. So write a function P in terms of n, so P of n. So we kind of already talked about that. The profit is the amount you take in, so that's your revenue, okay, minus your costs. And that makes sense. It should anyways, because the amount you bring in minus how much you had to pay. Okay, so I'm going to get rid of that graph for us. Okay. So the revenue function was 12n, and the cost function is 125 plus 7.5 n's. Okay, and when we simplify that, equals, we end up with 4.5n minus 125. Okay, so that's where it ends up being. So that's our profit function. And then identify the domain of the total cost, revenue, and profit functions. Now, the funny thing about this, okay, the domain of the cost function, okay, you can't make the total cost of all these things is 125. Okay, so there's the cost function. Well, you can't make less than 0 shirts. So the domain for C, domain for this cost function, okay, is n is bigger than or equal to 0. And that makes sense. It should make sense because you can't have less than 0 shirts. Now, the revenue function, the domain for that one, same kind of idea. It's 12n. Well, funny, you can't sell less than 0 shirts either. So n is still bigger than or equal to 0. And then the profit function, okay, again, you can't sell or make less than 0 shirts, so it is still n is bigger than or equal to 0. Okay, at least in the context of this problem. Range is a little bit different, but domain, that's how it's got to be for this particular function. Okay, so the key idea is you can add two functions, f of x and g of x, to make a combined function. You can subtract them in the same way. Okay, the domain of the combined function is the sum or difference of the two functions is the domain that's common to the two individual functions. So there's a nice little example here of kind of a weird one. Okay, so this guy, the domain for f of x, that's the blue line over here, that is x is less than or equal to 3. The domain of g of x, which is the red line, is x is bigger than or equal to -5. And so the domain of the added function, okay, the graph doesn't exist below -5, and it doesn't exist above +3. So the new domain is the parts of the old domains that overlap each other. So that's from -5 to +3. Okay, the range is determined from the graph, and then to sketch the graph, we just add or subtract the y coordinates of each graph. Okay, so that's that one. Now, to practice this stuff, I would like you to complete the following. So page 483, these are the numbers that I require you to do. Okay, you can do more if you want. Okay, remember guys, answers are in the back of the textbook, so you can check your work as you go. That's not a big deal. Okay, you can do them right from your textbook, or you can use the workspace card, which I do recommend because then you can print and write all over those sheets. So that's it for this section. We'll see you in the next one. Thanks.